Welcome to the WWC RDD Standards Training module focused on effect sizes and reporting requirements. This module describes the unique considerations needed when estimating effect sizes from regression discontinuity design studies, as well as two unique reporting requirements for those types of designs. After completing this module, you will be able to summarize how the WWC measures the effect of an intervention in a regression discontinuity design study. You will be able to summarize the unique considerations for effect size estimation in these designs, as well as describe the two unique reporting requirements for dichotomous outcomes and clustered samples. The WWC measures the difference between intervention and comparison groups on an outcome using an effect size that represents the intervention impact in standard deviation units. This means that the effect size is based on the variation of the measure in the analytic sample. Effect sizes are valuable for placing intervention impacts on the same underlying scale for different outcome measures reported in the literature that represent the same underlying outcome construct, even if those outcomes were measured differently in different studies in the literature. Using effect sizes to measure intervention impacts therefore helps improve comparability across findings in the literature, and they also allow the WWC to aggregate or synthesize impacts across outcomes and studies in order to summarize the entire body of evidence on a given topic. For regression discontinuity design studies that are rated meets WWC RDD standards without reservations or meets WWC RDD standards with reservations, the WWC reports two different types of effect sizes depending on the level of measurement of the outcome. For outcomes that are measured on a continuous scale, the WWC calculates and reports the Hedges G effect size, which is calculated as the mean difference for intervention and comparison groups divided by the pooled standard deviation. And for outcomes that were measured on a binary scale, the WWC calculates and reports the Cox index, which yields an effect size comparable to Hedges G. We will now review each of these effect size types in more detail. Again, for outcomes that are measured on a continuous scale, the WWC calculates and reports the Hedges G effect size. Hedges G is a commonly used standardized mean difference effect size indicator. For a given outcome measure, this effect size is calculated as the difference between the average outcome value for the intervention group members and the average outcome value for the comparison group members. And the net quantity is divided by the pooled standard deviation of the outcome measure. You can think of the pooled standard deviation as the weighted average of each group's standard deviation. A little more technically, if you look at the denominator, you can see that it's the square root of the weighted average of each group's variance that we are actually looking at here. In this formula, Y represents the means of the outcome measure, N is the sample size, and S is the standard deviation. The I and the C subscripts indicate the intervention and comparison group respectively. So the effect size estimate is the difference in group means, Yi minus Yc, divided by the pooled standard deviation, which again is the quantity in the denominator with the square root sign. Notice the omega included in the numerator. This is a small sample size correction. Without it, the effect size estimate will be upwardly biased in small studies. This formula, and in fact all of the important formulas that the WWC uses, is available in the WWC Procedures Handbook. For continuous outcomes that have been dichotomized, and for truly binary variables, that is, for outcomes with only two possible categories, the WWC uses a version of the Cox index to calculate impact estimates. The Cox index is designed to produce an effect size measure that is comparable to Hedges G. As shown on this slide, the formula for the Cox index includes the natural logarithm, written as ln, as well as the odds observed in each group. So in the formula, the p divided by 1 minus p term represents the observed odds. Without going into detail about the mathematical concepts behind all of this, the Cox index applies a natural log transformation to the odds for the intervention group, subtracts the comparison group's logged odds, and then divides that quantity by 1.65 to yield an effect size that is interpreted like Hedges G. You can find more information about this formula in the WWC Procedures Handbook. In general, the WWC calculates effect sizes for regression discontinuity design studies in the same manner as it does for group design studies. You may want to review Modules 3 and 7 of the Online Group Design Standards training. However, there are a few unique considerations when calculating effect sizes from regression discontinuity design studies, which we will now discuss. When estimating Hedges G effect sizes from regression discontinuity design studies, the numerator of Hedges G should be calculated as the difference between the predicted mean values at the cutoff for the intervention and comparison groups. These predicted mean values should be estimated only using data from the appropriate corresponding side of the cutoff value of the forcing variable. These predicted mean values must be calculated using the same statistical model that was used to estimate the intervention impact at the cutoff. For the denominator of the Hedges G effect size calculation, the standard deviations and sample sizes used in the calculations must be those from the intervention and comparison groups from the full sample, rather than those just within a bandwidth. If the standard deviations and sample sizes were used from within the bandwidth only, then this could lead to biased effect size estimates due to artificially truncated variance in sample sizes. Thus, the WWC will always calculate the Hedges G effect size using standard deviations and sample sizes for the full sample across the entire range of the forcing variable. When estimating the Cox index effect size from regression discontinuity design studies, study authors must provide the predicted mean value, or predicted probability, at the cutoff value, again with those predicted probabilities estimated using data from below the cutoff and above the cutoff, respectively. Again, both predicted probabilities must be calculated using the same statistical model that was used to estimate the impact on the outcome at the cutoff. These predicted probabilities are needed in order for findings reported by the author to be included in the rating of effectiveness. As discussed in greater detail in Module 9 of this training, in a regression discontinuity design study, clusters of students or other individuals might be assigned in groups to the intervention and comparison conditions. For instance, if schools are assigned to the intervention and comparison conditions based on school-level student achievement data, and if the outcomes of interest are based on students, this would be considered a clustered sample. However, almost all regression discontinuity design studies will also have clustering present in the sample when the design uses a discrete forcing variable, resulting in multiple observations or units having the same values of the forcing variable. For instance, if individual students were assigned to the intervention and comparison groups using a test score that has only 50 unique values, this would be considered a clustered sample because multiple students will be clustered within multiple values of the forcing variable. Clustering affects standard errors, but does not lead to biased impact estimates. So if study authors do not appropriately account for the clustering of students, a study can still meet WWC RDD standards if it satisfies the standards as described previously. However, because the statistical significance of findings is used for the rating of the effectiveness of an intervention, when observations are clustered into groups and the outcomes of interest are based on group members, study authors must account for clustering using an appropriate method in order for findings reported by the author to be included in the rating of effectiveness. Appropriate methods for accounting for clustering include bootstrapping, multi-level modeling, and robust standard errors, such as those proposed by Lee and Card in their 2008 paper. If the authors do not account for clustering, then the WWC will not rely on claims of statistically significant findings. This module described the unique considerations involved in estimating effect sizes and reporting on those effect sizes from regression discontinuity design studies. We discussed the Hedges G and Cox's index effect size that are used for continuous and binary outcome measures respectively. And finally, we discussed the unique reporting considerations needed for correcting the standard errors of effect size estimates from regression discontinuity design studies with clustered samples. The final module in this training series will focus on the Study Review Guide, which is the tool used by WWC reviewers to review a study against the WWC's RDD standards.